Thank you so much, George, for that kind welcome. And it's really, really great to be here in Taipei, speaking to the R user community here. I've met a few R user communities around the world, and it's just great to see gatherings of R users all around the world. To start off with, my sincere apologies. My Mandarin is terrible. I have been trying, but it's very, very terrible, so this talk will be in English. So I apologize for that. So let's talk about the art of data storytelling. Has anyone heard of this buzzword before, data storytelling? Has anyone heard about it in the data science community? Yeah, so a few nods around the room. Forbes Magazine recently called data storytelling the must-have business skill of the next decade. And there's really good reason for this. Businesses have a lot of data today, and what the data science community is doing is developing people who can do the architecture around this data and create nice visualizations and good statistical models. But the missing link is actually communicating the body of that data back to managers. And that's what this lecture is all about. How can we communicate to the rest of the business the insights that are embedded within the story? A little bit about my background. Data science has only been around for the last 10 years, so we've all come from different backgrounds. I come from a statistical background. So I used to teach statistics at the University of Canberra in Australia. And I used to teach statistics at the ANU in Australia as well. So I come from a theoretical statistical background, and about 5 years ago, I reluctantly started learning machine learning because my friend told me, these machine learning methods get better prediction error than the statistical methods. And I said, look, there's no way computer scientists can get better prediction error than statisticians. But then I looked more deeply into these methods, and I realized, wow, machine learning methods are really beating the crap out of statistical methods. And so I joined the dark side, and I went over to learn machine learning and started my journey as a data scientist. It was around 2 years ago that I really fell in love with data visualization. And I realized that there was just a lot of bad data visualization being done out there. And I actually hold Bill Gates responsible for this. It's so easy to create bad graphs in Excel. You just highlight your data, then you hover over, and then you get all these beautiful 3D pie charts and 3D bar charts. And it's so easy to create terrible graphs in Excel. And so a lot of the graphs that we see out there are really bad. And so I started looking into what makes a good visualization. And I ended up getting into D3 as a tool. I think R is a great visualization tool, but for just outright flexibility and interactivity, I do think that D3 is a little bit superior if you're happy to put the time into learning it. And so I ended up presenting a bunch of D3 visualizations in a TED talk where I looked at search engine traffic on Google, and I looked at how often do we Google celebrities versus the issues that really matter in the world, like global warming and poverty. And the results were not what you would hope. We certainly Google the celebrities a lot more than the important issues. What do I do now? I head up data science at a company called Altus. It's a machine learning and data science and data warehousing consultancy based in Sydney. And I'm also a trainer at a company called DataSeer, which is a data science training company. So enough about me. Let's actually get into how can we tell good stories with data. And I've come up with what I call the keys to data storytelling. And there's 4 keys that we need to satisfy in order to tell good stories with data. The first key is the audience, and this is arguably the most important key. Let's talk about the audience first. Okay, why is it so important to get the audience right? When we prepare a PowerPoint story, we have this idea, and I'm sure many of you have actually spoken to this group, right? When you prepare your presentation for the group, you have this idea that everything that you say is being consumed by the audience. When in reality, for some people in the audience, there is no learning happening at all, because they may not understand the tool that you're using, they may not understand the terminology that you're using, or the concepts you're talking about. Where we want to be is over here on the right, where we have meaningful learning. And I hope that I'm getting there with this talk, where every slide and every concept is being consumed and absorbed by that person and processed. In reality, where we often are is fragmented learning, because we have wide audiences, and some people are processing those concepts and other people are not. Now, this is so important in data stories, because data stories are often technical. What I mean by this is, let's say that I was presenting to a CEO. Now, hands up if you have a statistics background. Anyone have a background in stats? No? It's actually great. If you've taken courses in statistics or degrees in statistics, you'll realize that there's many more metrics other than the ones that are most commonly used. So the most common metrics testing. The most common metrics are the mean, or the average, and the mode, or the median. Test, yeah. So the mean and the mode, the total, I think I'll just ditch it. I'll ditch it. The total, these are the most common, might be running out of battery. Thanks. Oh, maybe, yeah, I'll just use that. Okay. So, testing, yeah. So the mean and the mode and the median, these are the common metrics, right? But there's all sorts of other metrics out there. So you've got, for example, there's the trimmed mean. There's skewness and kurtosis. These are other measures that we can use to describe a distribution. There's the quartiles, and there's more technical measures that we can use to describe a distribution. Now, if I was presenting to a CEO, I wouldn't necessarily use the mean, the skewness and kurtosis to describe a distribution, because that would be too technical for most CEOs, right? So we need to create audience-focused data stories. So the first thing to decide is, what is the appropriate medium to deliver the story in? So we could choose to use a PowerPoint medium, but increasingly we have to look at other media that's possible now. So you might want to present your data story as a D3 visualization in the browser. You might want to use a Tableau dashboard. So think outside the box as to the other ways that you could present your data story, even infographics. I was in Silicon Valley a couple of weeks ago. I met with IBM, and they're pioneering VR data visualization using Watson. So you can actually walk through your data visualization, and you can talk to Watson and say, okay, draw the XYZ axis, and you can actually walk through your visualizations now. So there's a lot of different media out there. Think about what's most appropriate for the audience. And let's select the metrics that are suitable for that audience. So again, not using standard deviation even. For those with a statistical background, the standard deviation is a number that is very readily understandable. But I know most of the C-level executives that I deal with, it's better to communicate a range or a max and a minimum to them rather than the standard deviation. Because I guarantee you, if I did a survey of 100 C-level executives and asked them to explain what a standard deviation is, you're not going to get a good response. And also choosing the right visualizations as well. So we don't want to use a visualization that's too complicated for our audience. So sticking to the more conventional ones, depending on who your audience is. Like if your audience is a bunch of engineers, then you can use a more complicated visualization. Okay. So continuing on the audience theme, the next thing we want to do is have a clear storytelling goal. So after you've looked at your data, step back and say, what do I need my audience to know? It's the big takeaway. Because it can be very, I mean, data is rich. And there's often, 5, 6, 7, 8, 9, 10 different insights that are contained in your data. And with limited space, sometimes you have to step back and say, what is the one key thing that we want to communicate here? And in the example we're going to go through, I'll show you how we can do that. Okay, so we're going to work through an example together here so that this is actually applied. And we're going to assume that, actually, would I be able to get that mic back? It's just a little bit hard to, George, would we have that mic?
Yeah.
I'll see how I go with the battery here. Let's see how it goes. Okay, so let's go through a case study. We're going to assume that we are consultants who are brought in to look at a bunch of airline data. And we're going to be presenting to the Chief Operating Officer of the airline. And the Chief Operating Officer is the decision maker in this example. And the data set concerns flights from Sydney to LA. And the Chief Operating Officer wants a recommendation as to whether to add additional flights to service the Sydney to Los Angeles route. So here is our data. I should have pulled this into R, given the community here. But anyway, so here is our data. And it's a very simple, very clean data set. And so we can see that we have seats occupied. That's the actual number in thousands. In each quarter, it's the actual number of people that were in seats for that quarter. And then we also have the number of seats that were available for that quarter. So for example, if we look at Q4 2016, almost every seat was filled in that quarter. All right, so which graph? How do we tell the story? What I recommend in this situation is to just produce a quick, dirty graph immediately. Just to look at your data, get a view for it. So this is not going to be the final form of your data story. It's a quick visual because looking at your data is a lot more, in a graph, is a lot more powerful than looking at it in its raw form. So we just produce a quick graph. Now there's a number of issues with this graph. But what this graph does tell us is it starts to give us some ideas about the main takeaways in the story. So we do see a seasonal effect. Every Q4, there is a spike in demand. So following the blue bar, there's a spike there in Q4. Going to Q4 here, not a big spike, but it did increase. And then going to quarter four 2016, we have somewhat of a spike again. We also see that when additional seats were made available, okay, notice that seat availability is flat until they seem to add more planes to the route. So all 78s along there and then 96 along there. When they added additional planes to the route here, notice that the occupancy climbs to fill that additional capacity. Okay, so it does seem that every time they've increased their seating availability, the occupancy has climbed to fill that availability. So those are a few insights here. Now, the Chief Operating Officer, part of her role is to make sure that when there's not enough demand, they're pulling planes away from that route, and when there is enough demand, they're adding planes to that route. Are there any ideas about whether we need more planes or less planes in 2017?
More.
Yeah, more planes. I like that. So there's a lot of different things we could say about this data. You know, we can talk about the seasonal effect, we can talk about all sorts of things, but really, the big takeaway, because remember, that's what we're trying to do here, is super important, decide what the big takeaway is going to be. You've only got 5 minutes with the COO, you're the data analyst, so you're closest to the data, and the big takeaway is we need to add more planes for next year. So we have to structure our entire data story around that. So I'm starting to visualize my story now. On the top, I'm not going to have a boring title like this. At the top, I'm going to have, please add more planes to this route. And we're the data scientists, so we got to add numbers as well. I need to say, add this many. And then the data, the story, has to support that request. So that's the direction we want to go. So let's go on that journey. So the big takeaway, we need to add additional flights to the Sydney to LA route in 2017. And this is actually really important because airlines, they spend so much money on their marketing, and there's going to be people ready to take that route. And if they don't have enough flights, then some of that demand is going to be going to other carriers. So it's very, very important that they do this. So we've now figured out who our audience is and what our big takeaway is. That's the first step of the data storytelling process. Let's move to the next step, which is the data. Now, we've only got an hour in this session, so I'm not going to spend a lot of time on the data. DataSeer offers a full 2-day course in data storytelling, and we spend a lot more time on how we can pre-process and clean the data properly, because obviously in the companies you work for, the data does not look like my data here. My data here is very small, very clean, no outliers, no blanks, no mistakes. Out there in the real world, your data set is going to be millions of rows long and high dimensional. So we cover all of that in our full course. But the one thing I did want to mention here is that we don't want to assume that the variables we have in front of us, we don't want to limit ourselves to those variables. And actually, the big limitation of using this data set to tell this story is I would love to have competitor data. I would love to have competitor data on how many flights are my competitors flying on that route in 2017. Because we don't want to go adding all these additional routes and then find that two of our competitors added routes to that same route. So think outside the box in terms of your data. The next thing I'll mention regarding the data is think carefully about what metric to use. So back here, I've just plotted the seats occupied variable versus the seats available variable. But you know, we could convert this into a ratio, okay? Or I could calculate the difference. What is the gap between seats available and seats occupied? So think carefully about metrics, but in the context of your audience. Because you don't want to come up with some complicated thing that, you know, they're not going to understand. But you could make a fairly strong argument that a ratio approach here could be more simple. What proportion of, what was our proportion of occupancy in each quarter? That could be a good option. Okay. Okay, but yeah, 1 hour talk, so we're not going to spend too much time on data. Just know that out in the real world, at that point, you would clean and process and choose the right metrics at that point. So let's assume, though, that we're going to stick with the raw variables that we've got. What is the next step? This is my favorite step. It's the visuals. Choosing the right visualization for the job. There's hundreds of different visualizations out there. We have the pie chart, the histogram, the line chart, the bar chart, etc. We have to choose the right one for the job, and once we've chosen the right one, we have to design it well. So let's talk about those two things: visualization selection and design. And Edward Tufte has a few things to say about visualization selection. And he says, so for those that haven't seen this guy before, I'm sure many of you have seen him before, Edward Tufte is the godfather of modern data visualization theory. This gentleman is single-handedly responsible for taking data visualization and making it a sub-branch of statistics with its own academic journals. So there's now researchers that devote their entire careers to data visualization, and this is the guy that started it all. And his guiding rule for visualization selection is, above all else, make sure you show the data. And that might sound obvious, but not all visualizations show the data. This visualization over here, it could be argued, is not showing the data very well. So we have this kind of, you know, we have curves on the grid lines, and it's just, obviously it's easy to get distracted by the monster, and so this is a visualization that is distracting from the data. Here we have another data visualization that's not showing the data, this one at the top. How many females are earning $25,000 or more based on this chart? It looks like maybe 690, 680 or so. But if we look at the 2D version, we see that exactly 700 females are earning $25,000 or more. So 3D distracts, and well, it actually conceals the real message. Okay, so we want to be doing charts like this, and like if we look at this graph compared to this graph, exact same data in each graph. But this graph is showing the data poorly because it's muddying the message with excessive grid lines. We don't need a blue background, and all of these take up cognitive capacity while your viewer is processing the visualization. So Edward Tufte came up with a way of battling what he called chart junk. Chart junk is anything on a chart that is not necessary to comprehend the message. Okay, and he was very mad about chart junk. And when statisticians get mad, they create a formula. And the formula is this. He called it the data-ink ratio. It's never a formula that you actually calculate. It's a formula that's just a way of thinking about visualization. And he says, take the total ink on the chart that's devoted to showing the data and divide that by the total ink that's used to create the graphic. And that results in a ratio. So to give an example here, this chart has a high data to ink ratio because most of the ink on this chart is devoted to showing the data. On this chart, is that shadow necessary to show the data? No, it's not adding to my interpretation of the data at all. It's a purely aesthetic indulgence. The roof on each bar is unnecessary. So much, the side wall there is unnecessary. So that's all this ink that's going on the chart, and it's not helping the viewer understand. Actually, it's not just not helping, it's misleading. Okay, so we want to pray at the altar of Edward Tufte, and we want to, above all else, show the data and have charts with a good data to ink ratio, a high data to ink ratio. Okay, so that's the first principle about design that I'll talk about. The next principle of design I'm going to talk about draws on findings from the Gestalt school of psychology. And these rules about how humans perceive their world have been around since the 1920s. So these rules are very, very old. But they have revolutionized quite recently the way we do visualization. And we don't have time in this class to talk about every single Gestalt rule, but I'm just going to talk about two of them. The first one I'm going to talk about is proximity. So if we have a look at this group of dots here, hands up if you see columns instead of rows. And hands up if you see rows instead of columns. Yes, most hands, yes. So, but in group B, hands up if you see columns instead of rows. Yes, and hands up if you see rows instead of columns. Not a single person. And the only difference between grouping A and grouping B is the proximity, the horizontal and vertical proximity of each dot has been modified. So because there's a closer proximity to the left and right here rather than up and down, we tend to see rows in group A and columns in group B because of that closer proximity. And this was a curious result that the Gestalt psychologists found. In C, we tend to see this as two distinct groups of dots rather than one big blob of dots. And so many decades later, some data scientists said, how can we apply this to our visualization? We're going to apply it in a moment. Before we apply the Gestalt law of proximity, I'm going to introduce another Gestalt law, which is the concept of similarity. And in A, hands up if we see columns in group A. Not a single hand. Hand up if we see rows. Okay. So, and why? Because this time, notice that the proximity is kind of the same, whether you go across or down. We see the rows because of the similarity. Okay, so what we're going to do is combine both of these Gestalt laws to improve our visualization. Okay. And that's what we've done here. What I have here is the exact same data that we showed before. And as an interim step, what I did was I created a line chart of the data. So those who've worked in Excel, most of you I'm sure, would be familiar with this utter abomination, which is the default chart that you would get if you created a line chart in Excel. And Excel puts the legend at the bottom. And so your eye has to do a lot of work. Your eye has to go, okay, blue line, and then read, and then go back, and it's doing a lot of back and forth. And so what we can do instead is use the Gestalt law of proximity to say, let's put this legend right next to the line itself. And let's use similarity of color to tie each legend to the corresponding line. And that's what we've done here. And isn't it a lot more simple to read the chart now compared to here? Okay, so using those Gestalt laws. Proximity, very close, and color, similarity, allows us to have the legend right next to the lines. This is in fashion in data science now. Okay. So here's the before and after so far. We're not done yet. Now, any ideas on why I went to a line chart instead of the bar chart? Yes, absolutely. If we're interested in the difference. The problem is that we are filling almost every seat here. So we're not so much interested in the raw magnitude, but maybe for another meeting that is, you know, what's interesting. But really, we're not interested in the height of these bars, we're interested in the gap between the bars. And if that's the case, we want to emphasize that there's no gap here. And the line chart does a much better job at showing the difference. Okay, so we're doing well so far, but we're not done. All we have now is a chart. What we want now is a data story. So let's keep pushing on. Okay, so it's time to add the narrative or the storytelling aspect. And this is my take on this chart. So, a few things have happened here. Let's walk through each additional aspect to make this a storytelling visualization. First thing I did was a statistical projection of what's going to happen in 2017. Okay, so our data actually ends here, Q4 2016. That was the last data point. There's a variety of techniques that you can use to project into 2017. Okay, there's probably some experts in time series analysis in the room here who could probably do a whole lecture on all the various techniques you can use. I've just used a very, very simple projection. So all I've done is I've said, let's take from Q1 2016, well, from Q1 2015 to Q1 2016, I go to the data and calculate what was the increase. And then from Q2 2015 to Q2 2016, what was the increase? And I get all of my increases. And then I just plus all of those increases to the 2016 figures to project into 2017. A very naive, very basic forecast. But the reason I've done this forecast is we have the COO listening to us, and we want to shock them into action. We want to say, look, if the increase in 2017 is the same as the increase in 2016, this is what's going to happen. Okay, there's that seasonal spike there. And right now, we've only got 96,000 seats available. If we keep that going, we have a shortfall here. and that's revenue left on the table. So please approve an extra 20,000 seats. Okay, I chose the number 20,000 because there's going to be a shortfall of about 16,000 here. Please approve an extra 20,000 seats for Q4 2017. Okay, because that's when the shortfall is going to arise. Now, I've used my judgment here. You might choose to have the additional seats in Q3 because there's already a shortfall in Q3. That's up to you to decide. I've color-coded the 20,000 to the seats available here using the Gestalt principle of similarity. And I'm explaining why we need to do this because we risk leaving that revenue on the table. And then to add a little bit more value to the chart, pointing out the two elbows here where we reached, well, the 2 points where we reached full occupancy. So I'm trying to communicate that, look, that's happened twice now. We're probably going to reach full occupancy again in Q4 2017. And note that there's so many things we could have said about this data, but we've honed and focused the COO's story on one big takeaway, which is give us the extra 20,000 seats. And now we're affecting change in the organization because we've told a good story with data that's understandable. Just one more example of a chart makeover. There was a survey of children and how they felt about doing science. And the responses are as follows on the left here. And then the children were enrolled in a program that was supposed to get them excited about doing science. And they were surveyed in a follow-up study, and it was all of the same children. There were no dropouts or anything like that. And they were surveyed afterwards, and the responses are here. So before and after the intervention. And we've used a pie chart for the before we do our data story makeover here. And Edward Tufte, who I mentioned before, had something to say about pie charts. He said the only thing worse than a pie chart is several of them. So what chart might we move to instead of the two pie charts here? Any ideas? Bar, yeah. Yeah, a bar could be all right, where on the x-axis we have each category, and then we have two bars next to each other. A bar chart would work reasonably well here. Before we move on to the makeover, let's understand why the pie chart gets so much hate. Okay, one of the reasons is that let's take the 40. Let's take the this slice, the 25% here, and then the 30% here. Okay. Now, the whole point of visualization is to communicate magnitude without having to look at the label. I mean, labels are good, but if you're going to be relying on labels, then just show your data in a table, right? The whole point of visualization is to communicate magnitude visually. Now, it's hard to assess the relative difference in size between this slice and this slice. One of the reasons is that it's changed in its location. It's kind of moved around the side of the pie. But humans just do very, very badly at assessing relative differences in slice sizes. I mean, I grew up in a family with siblings, and I can't tell you how many times we're slicing the pizza and it's like, that one's bigger than mine. Bad memories. So there's been some empirical research around this. So Cleveland and McGill did a whole bunch of research in this area, and they found that when looking at differences in position, so which dot is higher than another dot, we're very accurate at that. Or if you're standing at the finish line of a race, who's going to pass the finish line first? We're very good at that. Differences in length. Okay, so the stereotypical application here is the bar chart. 2 lines, 2 bars next to each other. We're very, very good at assessing differences in height and in length. Humans are excellent at that. Differences in angle. So if I drew a 30-degree angle next to a 34-degree angle, we're okay at that, but not as good as we are at these two. Same with slope, we're okay at it. Area, we're not good at this at all. And they've done empirical research here where they'll put 2 circles next to each other like this and ask people to guess how many times bigger is this circle compared to this circle. And some people will say, oh, it's 2 times bigger. Some will say 3 times, 2.5 times. And you know you've got a problem when everyone's disagreeing drastically on the difference. So anyway, Cleveland and McGill, great research in this area. Volume, this is why 3D bar charts are so terrible. We do very, very bad here. And then, yeah, color we do really, really bad. So that's why we do so badly here. So let's make over this chart. Here is the exact same data. And now I'm using position. So children or kids that felt okay about science before, they're up here 40%, and then they've dropped all the way down to 14%. So in this slope graph, this is a screenshot from Cole Nussbaumer's Storytelling with Data book. It's an excellent book. I recommend you go buy it. We see here, it's very, very easy to see the differences before and after. What Cole has done here is she's strategically used grey to push to the background the parts of the visualization she doesn't want us to focus on. Cole has a very specific agenda here. She wants us to know those that felt okay had a big jump down. That's the main takeaway. And she's using color to focus our attention on that part. And then she's using blue to say the 2 metrics where the positive metrics, which mean they're interested in science, those both got better. And she's using blue to bring those to the front. So a great learning I got from Cole's book is when you create your data story, when you create your visualization, make everything gray. In Excel, everything's black, or well, most axes and things like that are black by default. Start with gray, because gray is easier on the eyes. Black competes for prominence with other colors. Black is a loud color. I had a debate with my girlfriend the other day about whether it's a color or not, but black competes for prominence with the other colors that you have. So what Cole says is make everything gray and use color to strategically say, these are the things I want to bring to the front. Yeah. Okay. So yeah, that is, just summarizing, there's your before, there's your after. Google data storytelling and you'll see many great examples of telling stories with data on the web. Data storytelling is what I do, it's what I'm passionate about. We have a full 2-day course in data storytelling in Manila this January 23 and 24, and in Singapore, Feb 27 and 28. We're still thinking about Taiwan. Maybe we'll have a run here eventually, but for now there are no plans to have a training in Taiwan. We have a second course, Statistics for Business Applications. I was shocked to learn that many of the statistical methods I learned in my years of studying statistics were largely, not all of them, but a lot of them were useless in the context of high volume business data. A lot of statistics is concerned with statistical inference, taking a sample and using that sample to say something about a population. Well, for many businesses, we have the population. We have millions of customers, and we have data on all of those customers. So we have to modify our approach to statistics when we're dealing with those large data sets. We have a course on this, again, in Manila and Singapore. Predictive analytics is our third course. This is where we use models like linear regression and decision trees to make predictions about customers or whatever business metric you're trying to predict. And our fourth course, this is, for me, it's one of our most exciting courses. This is where we teach machine learning. So, and it's taught in R and Azure ML Studio. So we go through neural networks, random forests, support vector machines, all of the juicy models that get good prediction error. And we also teach how to think about the modeling process, how to think about segmenting your test and training sets, how to think about ensembling your models, and then squeezing out the last little bits of prediction error, like using bagging and boosting. And we teach everything from really first principles, so you know what's going on under the hood of your models. I'll hang around after George's lightning talk. Love to chat to you. If you want to get in touch, I have a Facebook page where I basically complain about bad charts that I've seen out there. Here's a particularly bad one that I shared the other week. So this was on TV in the US. I took a picture of the screen, and we see how concerned people are about the Zika virus. And somehow the 13% not at all is higher than the 34% very. And it was on air, and I'm watching it, and I just thought my IQ went down by 50 points as I was watching it. And it kind of went viral, so that was kind of fun. So yeah, if you want to see more stuff like that, yeah, my Facebook page is Isaac Reyes, data scientist. You can find me on Facebook. Yeah, so that's telling stories with data. Are there any questions about that? Yes.
Great class now. Just out of curiosity, instead of using color to differentiate different factors you're comparing, what about using like a dashed line versus a solid line versus something else? Like what's the thought behind that?
There's been a fair bit of discussion around that. Using, in R especially, there's awesome flexibility for either using colors or what they call in GGViz, I think they call it marks. So you can use, crosses or circles or, in the academic literature, they like to use different marks instead of color, because academic journals are in black and white. So that's the simple reason for that. I'm partial to color because otherwise you end up with a black and white presentation, right? So color brings your presentations to a bit of light. We saw with the 3D charts, it's possible to over-design your charts. Color allows us to using color the right way lets us allow color to serve a useful purpose, but without just using color for the sake of using color. So overall, I'd say, for example, if you were going to use a pie chart, which I'd not recommend, but if you just had to use a pie chart for whatever reason, then color is just a necessary addition. If you're using a line chart, then whether you use a mark or color, it's a much of a muchness. I don't know if they've done any empirical research on it, but I would just personally be inclined to use color because it makes your visual more engaging and interesting. Gee, that was a long answer for a simple question. Sorry. Any other questions? Yes.
I understand that it's difficult to convince, to tell the CEO about the student definition of the error bar, but sometimes it is necessary.
Yeah.
Sometimes you need to make sure that your results is significant. Then how do you present the class? Are there any way that you don't show the error bar, but still can show the idea that whether that result is significant or not?
Yeah, it's a great observation. We have been in that situation before where we've said to ourselves, for example, with an error bar, we actually tackled this exact thing where you might have the 95% confidence interval as your error bar. What we ended up doing was we worked in percentiles instead of confidence intervals. So for each point on the plot, we might say 95% of the data for this particular value lied within this range. If you can't get around it, then you may have to spend a couple of minutes explaining the concept if you can't get around it. But the point I was trying to get across here is that try to sit down and think about, is there a simpler way of explaining it? Because if there is a simpler way, because we want to avoid this, the fragmented learning. We want to do our best to simplify to that point where they're going to be able to consume it all. And, after teaching statistics to probably thousands of people now, the number of people that actually get confidence intervals outside of the statistical and mathematical community is very, very slim. And so that's why I'm always inclined to try to think of a simpler way of doing it. Thanks for the question. Any others? Okay, great. Well, thank you so much for listening. And I'll hand over to George.